Okay, here's part 2 of transformations. So now we have a vertical stretch and compression. So this graph is going to do something up and down because notice the number is on the outside. So we're going to affect this graph up and down. Okay. The key thing is, are we multiplying or are we adding and subtracting? We are multiplying. So anytime that happens, our normal graph, let's just say our normal parabola, looks something like this. Again, it is a parabola because it's x squared. Then our new graph, this is going to change the graph. So if you think about it, you plug something in for x, you calculate it, then you take half of it. So that's going to slow the graph down if you're always taking half. Like if I make $10 and you take half, I'm going to have a lot less money. So same concept, the graph is going to grow slower. The money in your pocket would grow slower. So the black graph is the correct one. So this is a vertical compression by 1/2. You are compressing the graph. So think about it, if you were to smush, think about a car crusher or just taking a rubber band or a piece of paper. If you pushed on it, it would bow out. You're vertically compressing the graph. Now we have this graph. We're going to start with our parent graph. Parent graph looks, I guess I should have stayed with red, huh? Trying to get it to go red. So our parent graph is this one. I'll shade it in. For these, I like to draw the parent graph so you can see what happens. So you draw your parent graph. What changed in the graph? Well, the 1/4, that's going to smush the graph up and down. So it's going to bow the V out. Going to make it look like that. It should be symmetrical. It's not quite symmetrical. It might be a little better over this way a little bit. But it's still a vertical compression by 1/4. The times means by. You can write the word by, or you can put an X that means by, multiplication. You're multiplying by a number. So here we go again. Our parent graph. Our parent graph kind of looks like this. Again, you still have to recognize what the parent graph is. If you draw the wrong parent graph, it's like showing up to lacrosse practice with a baseball bat. It doesn't work. People are going to look at you like something's wrong. So this is a vertical something. It's on the outside. It's being multiplied, so it's either a vertical stretch or compression. Notice the 2 is going to make the graph grow faster. If I gave you so much money and then multiplied it by 2, it would grow up faster. So my new graph looks like that. I forgot to highlight or star my final answer over here. So this is a vertical stretch by 2. We're stretching the graph by doubling it. So this is a vertical stretch or compression. This is a vertical stretch. Here we go here. We got our cubic function, so we got to go with our cubic parent graph. Cubic function parent graph. Let's say it looks like this. Here's my parent graph. This is going to make the graph grow slower, so it's going to be bowed out. It's going to grow slower. That's a vertical compression by 1/3. And then last in this group, our parent graph looks like this, a roundabout. Again, we're not going for artistic ability here. We're just trying to see what's going on. Oops. What does a 4 out front do? Well, it's something up and down. It's multiplying, so it's a vertical stretch or compression. We're going to vertically stretch this. Vertical stretch by 4. So here's the rule for it. Basically, anytime you're multiplying by a number on the outside, on the front of it, if it's bigger than 1, you're going to stretch it. If it's less than 1, you're going to compress it. If it's a negative, that means something else. So if this were a -4, it's still a vertical stretch. The negative would do something else, and we will get to that. So it's kind of you would just basically ignore that. The negative, it's something different. It has nothing to do with the stretch or compression. So now we get into horizontal stretch and compression. Notice, compare where the numbers were from these 5 questions to where they are here. All these things are on the inside. That's what makes it something horizontal. Remember I said anything that's on the outside is something vertical. If the number's on the inside, it's something horizontal. So we're still going to have our parent graphs in red. So better draw our parent graph. And again, if they're not perfect, that's okay, but I'm trying to make them as accurate as we can. So what does a 2 on the inside do? Well, we're affecting the graph left and right. So what we're doing, we're plugging in a number for x, and we're going to double that, and then square it, and then that's your y. So what that ends up being, that's going to make the graph grow faster. So it's going to make the graph get taller and skinnier. It still goes through 0, 0. Did not move up. This is a horizontal compression by, this is the tricky part, by a half. You are compressing the graph. So if you want to think about it this way, you are at the same height in half the time. You made the same amount of money in half the time. That's the way horizontal stretches and compressions work. Okay? So then we need to think about our graph here. Again, our parent graph is there. I forgot to star the black. Forgot to star the black graph over here as our final answer. So this horizontal, something inside, it's multiplication, so you're going to stretch or compress. You are getting at the same height in 1/3 of the time. And that means it's going to get taller and skinnier. This is a horizontal compression by 1/3. And then our black graph is our final answer. Not a very good star, but I think you see what I was trying to do. I'm clearly showing you what my final answer is. Okay, so here we got our square root graph. It looks kind of like that. And then we're going to draw our change. So this graph gets affected. It's going to be a horizontal something. So when this number is smaller than 1, but not negative, we're not worried about a negative, you're basically taking the graph and you're going to stretch it. Because this says that the graph is not growing as fast. Because you're plugging in a number for x, and then you're cutting it in half, and then you're square rooting it to find y. So my graph looks like this. So that's a horizontal stretch by 2. You're doubling the x values to try to get to the regular height of the y. Should be a little bit of a curve there, but okay. So now we got to draw our cube graph, our cubic graph. Our cubic graph kind of looks like that. So we're going to take our graph and we're going to horizontally stretch it. This number is smaller than 1, which means it's growing slower. So it kind of bows out this way and then bows out this way. That's a horizontal stretch by 3. Okay. And I forgot to star my final answer here. Okay, last one, a cubic function looks like this. Oop. See if I can undo that. There we go. Cubic function kind of looks like this. It's bigger than 1, means it's going to be compressed horizontally. You are making the y value, you're multiplying by 4. So you're going to smush the graph. So that's a horizontal compression by 1/4. So in 1/4 the time, the y grows, basically. So in 1/4 the time, the x grows. Okay? So here's the rule for it. It looks really confusing. I know that's written in mathematical terms. But if the number out in front of the x, it's still inside, but it's out in front of the x, is bigger than 1, it's going to be horizontally compressed by a factor of 1 over b. You got to flip it. And then if it's between 0 and 1, basically a fraction, between 0 and 1, the fraction is stretched horizontally. Okay. Last piece, and we will go to our third and final installment of our notes for this.